This video is about solving radical equations. It happens to be number 46 on the final exam review. And so this equation has two radicals in it, which makes it just a little bit longer than an equation if it only had one radical expression. So how you solve this is you isolate one of the radical expressions. And so if there's one that looks a little more complicated or more complicated in any way, you would isolate that one. So when I look at this, the square root of 3x plus 1 looks a little more complicated than the square root of x, so I'm going to get it by itself. So I do that by adding square root of x to both sides. So the square root of 3x plus 1 is equal to 1 plus the square root of x. Okay. Now you raise both sides by the power of the index. When I look at the index, I don't see anything, and that means that it's 2, because it's under a square root is understood to be the 2 right there for your index. So when you square both sides, the square root of something squared is just the something. What comes out over here is 3x plus 1. Over on the right, if we square 1 plus the square root of x, I'm going to do this carefully. I'm going to expand it. 1 times 1 is 1. 1 times the square root of x is the square root of x. The square root of x times 1 is the square root of x. And the square root of x times the square root of x is just x. 1 plus 2 times the square root of x plus x is what I get, because 1 square root of x plus 1 square root of x is 2 square root of x. So on the right-hand side, I get 1 plus 2 square root of x plus x. Now, if you still have a radical expression, and we do, we have to work on isolating it. So we subtract the 1 and the x from both sides to begin to isolate this radical expression. So on the left-hand side, we get 2x plus 0, or simply 2x. On the right-hand side, we get 0 plus 2 square root of x plus 0. So this is what we have. To finally fully isolate the radical expression, we divide both sides by 2. And we get that x is equal to the square root of x. Now we raise both sides by the power of the index again. So we square the left side and we square the right-hand side. On the left, we get x squared. On the right, the square root of something squared is just the something. We get an x. This is a quadratic equation, so I am going to get a 0 on one side. And you could use completing the square. You could use factoring. You could use quadratic formula for this. Factoring is the fastest, so I'm just going to factor out an x, leaving me with the x minus 1. One of my answers is x is equal to 0, and the other one is x is equal to 1. Now, the index was even, and so that means I definitely need to check to make sure I have good answers. Here's my check for x is 0, and here's my check for x is 1. You plug it into the original equation and see what you get. So, for x is 0, 3 times 0 plus 1 minus the square root of 0. Let's see. 3 times 0 is 0, plus 1 is the square root of 1, minus 0. Square root of 1 is 1, minus 0 is just a 1. Did we get 1? Yeah, we got, does this equal to 1? It does. It equals to 1. So this, x equals 0, is a good keeper answer. This is excellent. Here's the check for x is 1. The square root of 3 times 1 plus 1 minus the square root of 1. Does this equal to 1? That's what we want to know. Well, 3 times 1 is 3, plus 1 is 4. The square root of 4 minus the square root of 1 is 1. The square root of 4 is 2 minus 1. 1 does equal to 1, and so we got another good answer. We got 2 good answers for this one.